Hello everybody, I'd like to talk about fatigue test today for specimen size and structure size. Because it is not that easy to apply the load back and forth in high frequencies. The easiest setup is using the Moore test specimen. So we prepared a circular specimen here. So this is the cross section. And then we put the specimens on two support. So here we rotate the specimen like this. So we apply the rotation and then we apply load P and also P here. So let's say the spacing is equal to L and also L and L. Then in this place, so we have constant moment, constant bending moment, such that the bending moment is equal to L times P. Then if you identify a point here, say because of rotation, this point was on the top and it's moving downward, so here. So that's why the same point is experiences the maximum stress and the minimum stress, the bending moment times, and then because this is a circular specimen, and then diameter divided by 2, and a second moment of inertia. And that is the stress change during the rotation of the specimen. So if you plot the change of stress by number of rotation or time, it can be time or the number of loading cycles, then we have the change of stress like a sine curve. And then the magnitude, the change of magnitude is called the stress range. So if you do the test until the specimen completely fails, then we can obtain so-called SN diagram. The horizontal axis is log number of cycles before failure, and then usually the vertical axis is chosen as the log of stress range. Then for various stress magnitude, stress range, and then we have different number of cycles before complete failure of specimen. Okay, this is what we do in the specimen size. So instead of this rotating specimens, we can use uniaxial tensile specimen. And here we apply loading, compression, and tension. All right, this is what happens in specimen. So well, let's talk about structure size. In structure size, in structural scale, okay, let me show you typical set of structure scale. For example, a long time ago, I did for fracture test for the bridge deck. Here we fabricated the bridge deck using glass fiber reinforced polymers. That we put the specimen on the support. That we apply load here. Okay. And then another type, current, that's what currently we are doing. So we are doing a fatigue test for the grout joint for offshore wind energy support. So we put the shear connection stud here, and then we have another circular tube. And this circular tube supported here. And then these two tubes are connected by means of grout. That we apply load here. The problem regarding structures or structure scales, it is very difficult to apply the completely alternating load. So first one is very difficult to apply the complete alternating load. So what I mean, from minus P plus P. So instead of that, typically we choose to 0 to, alpha times the maximum load. Here the maximum load is, we usually, before do the fatigue test, we do the static test. From the static test, we measure the maximum load, and we apply load in the range of only the fraction of the applied load, the maximum load, P max. The alpha can be typically from 0.4 to 0.9, for example. Okay, and then another problem is in structural scale, it is very redundant because structural redundancy. Okay, structural redundant. That means it is very difficult to identify the point of failure. Difficult to identify, identify the point of failure. That means we need another indicator. Okay, this is very important. In the case of specimen scale, we can stop the fatigue test if the specimen completely fails, because the failure event is event happens very quickly. But in structural scale, because of structural redundancy, it is very slow, and the damage initiated at a point is spread out to the entire structural scale, and then we cannot continue the test because of large deflection of specimens. So for example, here what you can do is we can stop the fatigue test if you have any damage initiation, sorry. So it can be, instead of damage, you can consider crack, okay? Or in the case of structural scales, if you have only single crack, so you cannot say that the structure is completely failed. That's why instead of that, we may want to use the compliance change. Or in other words, you can say that the stiffness degradation, the degradation of stiffness. Okay. All right. Then in the structural scale, so now let's talk about the compliance change. Okay, so if you measure the static test, in static test, if you measure the load and displacement here, the displacement and load, and then what happened? If you do real test, initially you have a very flat branch, and then the response is almost linear, and then we have nonlinear regions, and it reaches to the maximum value, and then it softens. So this value is called the maximum load, or the strength, what I mean. And then this is initial flat branch, because usually it causes is due to the misalignment of specimens or the little adjustments. And then we measure the initial compliance from the initial branch here. This one, and then this initial compliance. And then in the sense of allowable strength concept, typically we accept about the 40% of maximum the load as the linear behavior of the specimen. Okay, let's talk about what happened to repeated loading. In the case of repeated loading, this is U here and the load P, and then let's say we want to use about 40% of the maximum load. Then the magnitude of load range is fixed, and then we apply load and then we unload. Okay, of course the initial slope of the compliance is equal to the initial compliance, and then but during the fatigue cycles the damage is accumulated. That's why gradually the curve becomes flatter, and then the compliance increases by the cycles of loading. And then here, the unloading cycle, during the unloading cycles, the response doesn't, recover to the origin because of plasticity or specimen misalignment. And that happens very often in fatigue test. That's why we have to stop the fatigue test and we have to adjust the specimen regularly during the fatigue test. So if you measure the compliance with respect to the number of loading cycles, then what happens is that this is compliance, and then this is initial compliance. Then by the number of loading cycles, compliance increases like this. And then we can specify a certain critical limit here. See critical, for instance. And then we stop our test at this point, okay? So once we have this criterion, then we can plot the number of cycles and then the load range in the log number of cycles, log the load range divided by the maximum load, for example, and then we can obtain the number of loading cycles. Let's say this is completely failure, for example. So you can say or collapse. But in real structural scales, it is very difficult to continue the test to have a real collapse because of large deflection. We cannot do that. So instead of that, we gather the data corresponding to a certain compliance increase. For example, you can consider 110% of initial compliance, or you can say 20% increase of the compliance. Okay, let me stop my summary regarding the fatigue test here.